Welcome, everyone. Today, my name is Andrew Vanderhaar. I'm the co-founder and managing director of the Fiber Carrier Association, and we are a trade association where we want to stimulate collaboration and open access on the fiber networks in the Netherlands. I asked Anouk from Deepomatic to tell you something about their solution, but before we do that, I tried to look for some background information, Anouk, and I saw a lot of French, and my French is not that good. So I thought I will look at some pictures, and I saw a lot of pictures on your timeline of VR and of expensive cars or luxury cars. Is that correct? Can you tell me something about that?
Certainly. I don't own the cars.
All right.
But I used to work in this industry before. And this is how I got accustomed to the world of image recognition and using image to maybe improve processes. And that's also why now today I'm working at Deepomatic, an enterprise software vendor specialized in computer vision.
All right. And you're based in Paris, that's correct?
That is correct. Yes.
Yeah. All right. All right. Keith, I did the same. I used Google search and I saw a lot of quotes, but a recent quote I saw was from just a few days ago in Total Telecom about right of way, and I think you're attending at an event.
Yes, right-of-way permitting is a necessary but painful exercise that network operators have to go through to augment their network. And we added that capability recently to our suite of services. And incidentally, it's not really related to the topic I'm speaking on at the gigabit access is on fixed wireless access. And in our case, how wireline networks are an important part and a necessary part to make a fixed wireless access network operate, and what considerations need to be made around powering, location, different elements that are not typical in a wireline only network. So thanks for that. I'm surprised you didn't find my pictures of motorcycles. I'll have to do better at that since you found Anouk's cars.
Yeah, but you're a motorcycle fan then?
Very much so, yes.
Yeah? Okay, what cycle do you have?
I have 6 of them, from a Kawasaki Ninja to a Honda Goldwing.
All right, all right. That's some nice power in the engine. Yeah. All right, okay. Anouk, can I ask you to tell us something about Deepomatic and what solution you came up with and implemented with some telecom companies already?
Certainly. I will present my screen. I'm Anouk, and I'm a sales director here at Deepomatic, dedicated to the telecom industry in Europe. We've been working in this industry for several years, and we've understood that the demand for fiber infrastructure and services has been growing year by year and quite exponentially for the past few years. We can see that the equipment is shared and there are several players working on it. And consequently to that, it is getting hard to enforce quality standards over the high volumes of service calls that are performed on a daily basis on this infrastructure. For the same reasons, it is also very hard to have a real-time status of the equipment that are, again, shared. So that has caused several issues, let's call them challenges, such as, for example, failures to connect the homes, customer churn, extra operational costs as well that were not anticipated and that are costing all telecom players a lot of money today. Deepomatic is an enterprise software vendor, as I mentioned it, dedicated to the telecom industry. And we leverage image analysis twofold. On one hand, we provide a real-time feedback to the technicians that are on site performing service calls to ensure that they do it right the first time. They don't need to come back a second time. On the other hand, through our tools, our clients gain visibility over the state of their infrastructure, but also over the state of the operations that are made for their account. This is obviously to prevent failures, maintenance costs, operational costs, things like that, that were again unplanned. Let's take a concrete example and see how it works exactly. I selected the case study of Bouygues Telecom, number 3 ISP in France, which we have been working with for the past 2 years. And first, I'll give you a bit of a context of what was going on back at the time before they knew Deepomatic, or before they were using Deepomatic tools. They have 3 subcontractors working for them on the French territory that are connecting homes to their fiber network on a daily basis. That represents around 3,000 technicians on the field, performing around 150,000 interventions per month. So the way it goes, they have those technicians on the field, mobile devices in hands, field service applications on their phone, and performing the interventions while taking pictures. Those pictures were then checked manually by an audit team, and those are the 25 people that I'm mentioning here, located at their network operations center. And this is a Bouygues Telecom corporate team. Those people were checking on a daily basis as many interventions as they could. Unfortunately, being 25 people for 150,000 interventions per month allowed them to only check manually 8% of those. The problems they identified in their process at the time, there were 3. First of all, like I mentioned, they were capable of auditing 8% of the interventions, so they had a hard time to really control the subcontractors' quality of work. Second of all, they came to understand that there were quite a high rate of re-intervention, where the technician of their subcontractors needed to come back again on site at the customer's home. And that leads me to the last point, which is customer satisfaction. We all know that the interactions should be as few as possible and as frictionless as possible. Unfortunately, a technician that needs to come back puts a lot of friction around it. You need to rebook the appointment, ensuring that the client is here. That's not sure for sure. So it's getting a bit messy. And those were the problems they identified. From there, they selected Deepomatic, as I mentioned 2 years ago, to cope with those challenges. And we'll see right now what solutions we put in place for Bouygues Telecom to cope with those. And we'll start with what's going on the field with Deepomatic tools. So what you see here is really from a technician perspective. The mobile device in hands, through their field service management application, the technician is taking pictures just as they did before. They still have a work order, and within this work order, they know exactly what is to be done, what are the checkpoints to be validated, to be compliant with the quality standards of Bouygues Telecom. So here, for the example's sake, we decided to show a street cabinet, and there are 4 checkpoints to be validated. First one is about having a contractual photo of the street cabinet. So the technician has taken the picture, it will be then analyzed by Deepomatic tools. And in real time, a result will be sent back to the technician. Here on the picture, we can actually see a street cabinet. It is opened. We can identify the items within it that defines the street cabinet. So we send back a result that says, okay, this checkpoint is valid. Moving on to the next one, we'll check within the same picture if the labeling is valid too. And it seems to be the case. So again, result is sent back to the technician saying, okay, everything is all right so far. And then comes the third checkpoint. We are expecting no unconnected fibers within this street cabinet. Unfortunately, as you can see, there are several of them. So on top of pushing back this result to the technician, we are drawing boxes, we display boxes around the unconnected fibers that have been detected by our AI-powered tool. And those are the red boxes you can see on the mobile device screen. Same goes for the next checkpoint. Patch panels are supposed to be parallel in good shape. However, on the picture, we can see that they are collapsing. Again, a result is sent back. It is not okay. It is not compliant. And I'm letting you know it is displayed through the interface of the field service management application. At the end of the intervention, the technician will want to close it as they used to. And here there will be a pop-up mentioning the checkpoints that were considered as KO by Deepomatic AI-powered tool. Here, as you know, we have two of them. We have unconnected fibers into the cabinet, and we have patch panels that are collapsing. So that's a reminder. However, Bouygues Telecom decided that those specific checkpoints were not blocking anomalies. That means that the technician can still close the intervention. But Bouygues Telecom could have said, okay, I do consider those as blocking. And in that case, the technician wouldn't have been able to close the intervention up until those problems would have been fixed. So now the technician closes the intervention and move on to the next one, and it will go on the same way as I just presented to you. Meanwhile, we have provided the employees at the Networks Operations Center with a web-based interface that we call the monitoring dashboard that allows them to gain that visibility I was telling you about what's going on the field exactly. How are my subcontractors working for me? How well are they doing it? And can I do something about it? And this is the place where you find this info. So first screen, that's the one you see right now, is pretty much the listing of all the interventions that are currently happening or that are already over, with a status on their compliancy towards Bouygues Telecom's quality standard. As you can see, several data are attached to each intervention: the subcontractor's name, the location, the use case. Here at Bouygues Telecom, we are talking about 3 subcontractors and a FTTH use case, 150,000 interventions per month. Obviously, as you can imagine, they can filter the intervention that are displayed here. They can filter them by criticality level, by subcontractor's name, by date, and so on and so forth, to ensure that the few manual audits that they perform are on the right interventions. So once they identify one intervention that caught their interest, the employee can assign it to himself and gain access to more details about it and have actually the info of what really happened on site and what were the results of Deepomatic tools. And that's what you see right now. For every checkpoint, the picture that was taken is attached. The network operations center employee can zoom into it, can see the AI result, and can also change that result. For some reason, maybe it could differ, his judgment could differ from the result of the AI, and this is the place where he can actually change the result. Also, they have here access to a timeline. So for instance, and that's a good info for them to monitor how well it's going on the ground. They can know, for example, if a technician had to take 3 photos for the same checkpoint. Maybe there is something wrong going on. Maybe the technician is ready to cheat for some reason. Maybe he's just having a hard time. Maybe the photo was blurred. These kind of info are logged into the timeline, and Bouygues Telecom can act on it. Maybe schedule a new training session for his subcontractors technicians. All the info that are in the monitoring dashboard at an intervention level are aggregated within a second dashboard that is about business intelligence. That's how Bouygues Telecom drives and monitor the value that Deepomatic's platform has brought to the organization. Value is monitored through different KPIs, and the full dashboard has been fully customized to Bouygues Telecom's needs. So for instance, they wanted to know how well their 3 subcontractors were performing for them. So we know exactly which one performed the best, which one are maybe a bit less good. We know the same information depending on the region in France. We also have KPIs monitoring the checkpoints themselves to see if some of them may not be that relevant in the end. And that actually happened with Bouygues Telecom, who considered that one of them was too complicated or not appropriate towards the process, so they change it. But they are also here capable of measuring the impact on the business by how much the reintervention rate got reduced, by how much the customer satisfaction was improved. And all of those KPIs have been tracked for the past 2 years within a single dashboard that is today shared across several types of profiles, but mainly operations director and customer satisfaction directors or department. Let's talk about the benefits. After using the platform for the past 2 years, Bouygues Telecom shared a few of them with us. The first one, you may have guessed it already, is about their ability to now control 100% of the work that is done for them. Remember, it was 8% before. Second of all, their customer satisfaction rate has improved consequently. They became number 2 in France recently. Obviously very proud of it. Let's not say it's 100% Deepomatic, but we know we played a big role in it though. Third one is about the first time right rate. I mentioned it. This is an important factor into a frictionless experience for the end customers. So today it is over 85%. It has improved by around 30%. But on top of being a benefit for Bouygues Telecom, it is also a benefit for the subcontractors, technicians, the subcontractors companies, because for them, it's about having more productive technicians. They don't need to come back for free on a second visit. So this one benefits all of the organization for this contract. Another one is about the average duration of the intervention. 2 years ago, apparently it was around 4 hours. Today, it has been cut by half, meaning that Bouygues Telecom and their subcontractors can do more per day and do them right almost all time the first time. And last but not least, the payment of the subcontractors is now way more accurate. Again, this is due to the visibility that they gain over the operations on the field. Because they are now able to control 100% of their interventions, they know exactly when to pay the subcontractors, for what reason, and when. And that has improved their treasury as well. To conclude, the telecom industry has become strategic for Deepomatic. We've been working with several players, ISPs, subcontractors, now with wholesale carriers as well, on different types of environments. As you can see here, fiber to the building for Swisscom, FTTH, as you understood, for Bouygues Telecom, fiber to the curb and fiber to the home for one of the subcontractors in France, that is Sogetrel. Our platform adapts to your own environment, to your own specificities, to your own business rules and checkpoints. And that's the reason why we are able to accompany all these types of organizations and bring them value on a daily basis. Thank you very much for listening, and feel free to ask any questions.
Yes, thank you, Anouk. We'll start my video again. Very interesting. I don't know if anyone has a question for Anouk, then he or she can unmute. Okay, well, I do have a question because you in the beginning, in the first sheet, you said 3,000 people were on the job for intervention. So that's 3,000 mobile devices and subcontractors. How do you manage that everyone has the right access so they don't get the wrong intervention job?
So our tools are integrated within the existing workforce management applications. At Bouygues Telecoms and their subcontractors, it appears that there are in-house applications. So we provided our API that got connected through the existing system that is receiving the work orders, the right work orders for the right intervention.
Okay. So because I can imagine that several subcontractors don't need to see other subcontractors work from Bouygues,
yeah,
from them.
That is correct. But the overall visibility of all the subcontractors' work is given to Bouygues Telecom's networks operation center employees. Those people have access to all the work, but obviously at a subcontractor level, they don't know how it's going for the one next door.
No. And if there's a not valid, then the employee is not able to do the work or to finish the work, or he has to notice that on the red screen with 2 interventions were not valid. The brackets were collapsing. Then he can't finish his job. He needs to get back for the second time, or he needs to call to the operating center. How does that work?
If it is considered as a blocking anomaly, either he knows exactly what he needs to do to repair it. For example, the patch panels, probably he would just need to unscrew a screw and put it back up and fix it, pretty much. So in that case, he just do it up until the last picture he takes shows that it's compliant, and then he can validate and close the intervention. For more complex KO, let's say, on checkpoints, Bouygues Telecom would be able to help. So they would call their manager to see if it can be repaired right away, and if not, they would close it, but with a special code that will be mentioned in the monitoring dashboard, and indeed a second visit then would be scheduled.
Okay. And the smart software is the AI, and in the back end, they can identify the changes. But if engineer changes, then the AI knows the patch moved from A to B, or he repatched it.
Yes, that is correct. Every changes, it can be manual or it can be automatic. And then it is integrated back to the last version of the application, visual application. So we ensure that it's continuously improved by any feedback from the technicians or from the network operation center employees.
Okay. Yeah, because is it easy to implement in your in an organization? Because I think from engineers, I can imagine they have quite a resistance, because it's a change of way of working with although they have the device and they already had to make a photo. How do you manage that part? Does Deepomatic help the customer as well on that part?
Thank you for your question. It's a very interesting one. For Bouygues Telecom, from a technician point of view, the gap was not that big, for a simple reason, that is, they were already taking pictures before. They were already using the app. They were already taking pictures. So the only difference is that they know in real time if everything's all right or not. However, we make sure that during the setup phase is where we configure our platform to learn the specific environment of Bouygues Telecom, their specific checkpoints, their specific business rules, and when we implement them. And during this phase, we make sure that field people are involved in the specification of the needs, ensuring the adoption later on. But you are right, it's still a change in the process, and it takes a bit of time. It has been requiring some training as well. There is a Bouygues Telecom Academy, and they upgraded their content to integrate the way of working with Deepomatic on the field.
Okay, and that's really helping the technicians on the field. And it's a physical training, or it's an online training academy, or?
I say it used to be physical. Now we have to deal with the situation, as you know.
Yeah. Thank you, Anouk, for sharing this info. If you have later on a question, then just ask the question to us. Then we'll come back to Anouk. Then we'll going to ask Keith, because we saw why is it so interesting for the software. With Deepomatic, you will see the solution at when it's already implemented. But before it's already implemented and the physical fibers are in the street cabinets, it needs to be designed. And IMMCO knows everything about designing, they told me. So I'm really curious what you can tell me, Keith. Keith is not in Europe at the moment. And the fiber connections subsea are terrific. Because we don't see any delays.
Yes, I'm showing 37 milliseconds of latency on my connection, so not too bad for going across the pond. Thank you, Andrew, and thank you, Anouk. Really intrigued with your software for two reasons. One is most of my career was spent running engineering and operations, and having real-time validation of the accuracy of a installation would have been a game changer when I'm trying to coordinate 1,000 technicians in Los Angeles, California back a long time ago. I wish I'd had that tool. Secondly, the AI ML you're using to do the photographic validation, we have an application that does a similar thing to look at outside plant infrastructure, the size of a pit or vault, the tower or a pole, is it concrete or metal or wood? What's on the pole? Is it primary power, secondary power, fiber, coax, et cetera? So it's the AI ML capabilities are really starting to take some tedious nuance out of the inside plant and outside plant business. So I have a few slides and more importantly, some discussion about what IMMCO's done with software to improve the accuracy, the speed, the efficiency of network deployments. And it's one thing doing it on the design front, but the example I'm going to mostly spend my time on is really before the design, and it's on collecting network intelligence of either what is existing in a current network where it's deployed, or if there's no network deployed, what's existing in that area in terms of physical infrastructure that is not included in network mapping from the municipality or perhaps from a power company that you might be working with, or even from resources such as Google Maps or Bing Maps. So in the US, we call this data collection field walkout, that we send a team out into the field with various tools such as laser measuring equipment, measuring wheels back in the past, maybe a precise sub-foot GPS receiver that is placed at the point where a network element exists or a network element is proposed. And most of that data to IMMCO as a design company, regardless of how it's collected, comes in a paper, almost a paper format. It's a PDF file, perhaps with some associated data in an Excel document to put the latitude, longitudes, notes, pole owner, pole tag, that type of information. So we built a tool many years ago that originally was a desktop tool that we've now ported into a mobile tablet environment that does a lot of that data collection automatically. And instead of having to have penciled in notes, it has drop-down tables, it has pick lists, and it integrates into a database that then ties into our design tools. And it doesn't have to be our design tools. It can tie into your particular ones. We even use this tool in a particular circumstance that we're doing some of the design and another design partner is doing another area, but the field people use our tool so that both design partners are getting the same level of accurate digital information. And it's got rich tie-ins to it in terms of things like photos of network elements, just like we saw from a nuke. We can have a photo of what's inside a pedestal, what's inside a vault. We can have a photo with an angle to show the attachment height of a particular pole attachment. So let me advance a slide here and show you what some of this looks like. Before I get into this, this particular one I'm going to show you is tied into a smart city project. So this particular one, we've done several of these, but this particular one was in California, and it's a mid-sized project, 35,000 addresses. And it ended up being about 100 miles of in the US, we call it micro trenching. So it's trenching inside, instead of in the public right of way, it's actually in the road. So a trench is dug about 6 inches in width. So let's see, that's 15 centimeters, give or take, about 2 feet deep. And then a small conduit with even smaller interducts is placed inside that micro trench. The road is then restored, and these conduits are then, they have intercepts to go to the the sidewalk area or the yard area of a residence or the building connection point for a commercial building. In this particular case, the routing had to be diverse for commercial locations, so they had to have two different feeds coming from two different directions. So if there was a cut in one, their service would be provided by the second one. And for smart city, there was a lot of demand points that had to be designed, things that the municipality knew about that they wanted, and things that they thought they might want in the future. So, things they knew they wanted were, traffic cameras where they were currently existing. They wanted to put them into the smart city network so they weren't paying for a second party to connect them. Things like water and sewer flow meters, interesting things that, gunshot detectors that, triangulate where a gunshot is detected so the police know where that location is. And in this particular case, the design planning had to not only consider fiber for that, but also in some cases power, centralized power. So the fiber would need to be included with a twisted pair of copper conductors so that you didn't have to have distributed power at each location. You could, some of these demand points, you could provide centralized power to. So we actually had two different pieces of software that were deployed here. One that was externally deployed with the field team doing the as-builting, which was digital field data collection. And then we have an internal tool that we used that loaded in the business rules for this particular network design, and then created automatic route design that not only incorporated the business rules, but also would make it as efficient in terms of staying away from areas that were expensive to construct, like environmentally sensitive areas that had additional permitting, like historical districts that if there was a way to avoid, you would do that. We've got another application or another city that we're doing this in that has things like cobblestone streets that are a different, far different construction technique. You can't do micro trenching in cobblestone streets. You have to do, either cobblestone removal or perhaps directional boring. So we build those business rules into the application to make the design not only work from a performance perspective, but also to make it easier and less expensive and more rapid to deploy. So IBIS is our field tool, and it's essentially a bird's eye view coupled with a map, coupled with a database that connects the field data environment, all the technicians collecting the field data with the engineering team, and has a unique capability of collaboration. So if a field agent is out in the field and his network schema says that there's supposed to be a 1 meter by 0.5 meter vault that's going to have enough room for a splice box, and he gets out there and he finds that the vault is actually a half meter by a quarter meter box and is not big enough to accommodate that splice box. Instead of having to wait for his map to get brought back into the office, the engineer sees, oh no, what I'm going to do, I don't have a big enough vault. The field tech can create a immediate chat, video conference, or phone call with the design engineer, and real time while he's in the field, send pictures or video of what is there. The network engineer can then say, well, can you go look and see if the vault that's 300 feet further down the road has enough space? Maybe we can move that splice box from this vault to the next vault. So it speeds up the network deployment. All of those changes get added into a database so that when the final mapping is done, who was involved, why an initial change was changed to the final result, and who the decision maker was on it. So if there's questions, who the design engineer was, who the field tech was, where the exact location was, and you have a kind of a real-time as-built that's there for your network documentation. If you can see my mouse, we have a whole lot of tools, everything from a, you can pull up Street View, you can pull up your exact location on a Google aerial, Google Map aerial. You can request additional information. The tools on the left are data entry tools. You can draw a red line, you can take a measurement, you can attach a photo, you can put in notes, and all of that goes into each one of these colored boxes shows the status of the network at that point. So if it's green, everything's good. There's no issues. If it's yellow, there's a minor issue, but it's not an impediment to construction. If it's red or purple, you can't send a crew out to do that construction because there's an issue that needs to be resolved. Maybe there was an expectation that there was an available duct, but upon field inspection, you find that there was not a duct there. So you have to go figure out what the remediation would be to get that done. And the desired outcome for this tool is you have first time resolution when you send a construction crew out to do their task. They don't get out there and find that they don't have the right size pit. They don't get out there and find that a rope has not been pulled through the conduit. They don't get out there and find that they don't have the right equipment because it was anticipated that it was going to be a asphalt cut, and it turned out it was actually a concrete cut. If this tool supports collecting all that data on the front end so that you have a much more efficient network deployment on the back end. The tool ties into databases that show you your percentage of completion, and then the types of work, hauling through conduits, splicing, how much of it's aerial and underground, and all of that is real-time and interactive. So you can, for example, in the desktop application, you can click on any of those boxes, and all the data that goes into that box shows up in rows and columns with timestamps, with approvals, all the the building blocks that went into this network environment. I don't have it in the slideshow, but this rolls up into an executive dashboard so that you can see day by day, sector by sector, whether it's a work zone or a node, however that environment is being tracked. You can see, is it green? It's on task. It's meeting the expected deadlines. It's yellow. It's behind deadline, or it's more, it's taking more equipment, more network footage than you might have anticipated, and what those reasons for that is. Or it's red. There's a barrier. We cannot construct there because we've got to replace a smaller conduit with a bigger conduit, or we have a permit that's being delayed by the municipality. So that's the short version of the field tool. It's got a lot of enhancements. So while it's one tool, IBIS, we have several flavors of it for different network topologies. So we have a fiber to the home flavor. We have a fiber to the curb flavor. We have a hybrid fiber coax flavor. We have a smart city flavor, and we have just deployed a fiber to the node extending to the home project that we've enhanced it to support that particular network topology. So it's agnostic, it's browser based, so it can work on an iPad, a Lenovo tablet, as long as you have access to a browser such as Google Chrome, Internet Explorer, any of the browsers it'll work on. So it's not tied to a particular app, and it uses the capabilities of the tablets in terms of GPS receivers, photo and video capability, along with local data storage, so that if you are going out to do a field survey in an area that doesn't have good network connectivity, we can load in all the network mapping that you need into the tablet so that it's able to be processed in the field even if you don't have internet access. So that's the quick and short of a couple of the tool sets that we have and what their capabilities are to improve the design and construction of your network.
Yes, thank you, Keith. Then I have a few questions. I see at the last slide also a manager's function of total completion. There are different parts of the software that are engineers, designers, because I know for the Netherlands, we bury everything in the ground. As I know, we don't do the micro trenching in the roads, but how did you come up with that solution? Because it's a very good solution, I think, just opening up the roads for 15 centimeters and place the duct.
That's been around for, I don't know, probably more than 10 years. Google Fiber was probably the biggest user of that in the United States because it speeds deployment. You don't have to worry with, digging up people's lawns. You don't have to, you do have to get permission from the municipality to deploy it. The challenge is if the restoration of the road is not done properly, the trench can either sink in or bubble up, which causes problems with the smoothness of the road and even the structural integrity of the road. That process has gotten better over time and more accepted by municipalities. The other challenge of constructing in the public right of way is there's so much already there. You have at least two telecoms, the cable telecom and the legacy phone telecom, that are in the public right of way, plus all the municipal things like power, water, sewer, gas, perhaps other telecom for the cities for traffic control or other things, and there's the constant risk of damaging existing infrastructure in the public right of way. So yes, there are things under the road. There's sewer lines, whether it's storm sewer or sanitary, that have to be avoided, but the cities tend to keep better documentation of what's under the roadway than what we've seen typically in the public, in the right of way outside that roadway. So it's really while it's more expensive to construct with micro trenching, it's faster. So your opportunity cost of getting your network out more quickly is offsets that higher cost of micro trenching construction.
Yeah, of course, you can predict better the rollout phase at the end. Okay, that's very interesting. And I saw a gunshot shot detection that's really caught my attention. But that's on the smart city project. Then, if a network is really rolled out, then they want sensing on the light poles or.
Yes, so many cities have hundreds, if not thousands, of security cameras. Some of them may be fixed, some of them may be able to re-aimed. And what the gunshot detectors do is twofold. One, it gives the police an alert that the gunshot has gone off, within a couple hundred meters of where that location is. But the smart cities, they integrate those gunshot detectors with their cameras, so they immediately train the cameras in the direction of the gunshot, both for live feeds and for recording, so that they perhaps can catch the vehicle as it's leaving the scene of a crime. And the thing with gunshots is during periods of celebration, 4th of July in the United States or New Year's Eve, it's overshot with fireworks. It can be, but they're typically only used in inner city locations. This particular one we were involved with was in the Los Angeles area. It's not, if you have it in areas where hunting is going on, it's going to be giving you more false information than positive information.
Okay, and how is it in the United States with designing and rolling out? Because you mentioned the asphalt with that you have a concrete barrier or something. How detailed does the municipality give information, or do you have a central agency for that who keeps track of that?
The answer to both is no. The municipalities know they have a road, and let me give you a great example. The project we're working on in California, the road, the asphalt was in very bad condition in parts of the city, but it was in good condition in other parts of the city. So when the construction started, the micro trenching was essentially damaging the asphalt because it was already chipped and cracked. So the company we're working with asked if we could go help them do an assessment to see what the condition of the roadway was. So we use some AI pattern recognition software and use Google Street View to assess the quality of the asphalt. Now, yes, it might have been somewhat dated depending on how recently the Google photos have been taken, but in most cases they were 2018 and newer, so they were pretty recent, and we were able to give them a very high level of accuracy of what was a good, better, best road condition, so that they knew what their resulting construction difficulty was going to be.
Okay, that's because what we have in the Netherlands, if you end up with a road that's a bit bad or something, you need to restore that road better than actually it was before.
Correct, same thing here, and that's the really bad roads you have to repave. There's no way to, but that comes at a cost, and that comes with some, time, because the micro trenching experts are not paving experts. So, that has to be a secondary effort with a secondary contractor. But if you know that before, you can add that into your cost planning and your timeline planning.
That's something you already place in the design when you're designing the network before the contractor says, well, it's okay, then they already know what
Sure, and that's one of the learnings we had jointly with our partner was when we moved from the California project to one we're working on in New England, that roadway assessment was part of the deliverable. So we did that on the front end to give them the ability to do an accurate cost estimate before we actually got into the final design. They knew what percentage of roads were good condition, what percentage were bad, and what had unique features like either cobblestones or granite curbs, things that were going to require additional expense and potentially different equipment.
And do you also inform contractors about new possibilities that they really were focused on not micro-trenching, but on aerial connections or something like that?
Yes, in other environments, and our IBIS tool works in both aerial and underground. And so, for example, you saw a tick list of, is your conduit in place? Is rope inside your conduit? Has your fiber been pulled through the conduit? All of those building blocks, that happens with aerial too. Have you got your pole permits to be able to attach to the pole? Has your strand been put up? Has your fiber been lashed to the strand? Has your fiber been spliced? Has it been tested? All of those building blocks go into it. And, we, with our intelligent routing application, we look for not only the shortest route, but the least expensive route and routes that avoid things that might create delays. Like if you have to go in the United States, we have American Indian tribal areas in a lot of parts of the country that have very restrictive access. We have military bases that have wide areas, even outside the military base, that you have to get permission from the base to work in those areas. So we build in those areas to avoid, if at all possible. Sometimes you can't avoid it, but if we can find an alternative route, we'll recommend that to our clients so that they can lower the cost and, more importantly, lower the duration of their project.
Yeah. Okay, very interesting. For the viewers, IMMCO Inc. is not only active in the United States, so they're already active in Europe and Australia. I think you have a branch office or headquarters.
We do, yes, and we've done work in Malaysia and South America, several countries in the Middle East. Telecom is based on the rules of physics, and those apply across the planet. So, we work all over.
That's an advantage. Okay, thank you. Are there any other questions from the audience during this session? Then I'm going to thank you, Keith, for sharing your view on how to save money on building and designing. And I think we're almost at the end for wrapping up. But before we go, Keith, you didn't receive this one. I'm just like a table host presenter. This is our news report on the Netherlands on fiber. So for
good.
most of the people in the Netherlands, we sent out the report in Dutch. If you didn't receive it yet, send me an email, then I will make sure that you will get the report. We also it is written in Dutch. We also are translating it into English. So for Anouk and for you, I will send a copy in English.
I
Oh, very good.
appreciate
Thank you.
it, Andrew.
Sorry?
Appreciate it. Thank
Yes.
you.
All right. Then if there are no questions left, then I'm going to close the formal session. If you want to stay as a viewer and you want to share some knowledge, you can open up your video screen and unmute, and we can have an informal discussion. So thank you for all attending, and until the next mini college.